All right, here we are, section 8.3, and it is titled Graph General Rational Functions, and it basically should maybe instead of general say all possible types of rational functions, and there are so many. So the general form, here it is, general form, any polynomial equation, and x to the power m, meaning you can go x to the power 5, 6, it doesn't matter. It's basically take any polynomial divided by another polynomial, and that is a general rational function. So we have three tools that we use for graphing, and let me make something clear. I'm really excited that we're doing this section, and I know it's a very difficult section. So I think I'm going to not have you actually do any graphs, but I'd like you to be able to identify graphs and identify different parts. So hang with me, kind of trust me. I'll have a nice worksheet tomorrow, and you'll see what I'm expecting of you. I do expect that you can figure out the x-intercepts of the graph. How do I do that? I basically take the top part of the rational function and set it equal to 0, and I solve and I find the x-intercept. So let's look through the examples real quick. So here, the first one, you would set 3 equal to 0 and solve, and you don't get an answer. And so check it out, no x-intercepts. Here's the next example, right? Example 2, set the top equal to 0 and solve, and you get 3 and -3. And check it out, there are your x-intercepts. Look at example 3, set the top equal to 0 and solve, and you would factor, and you'd see that your x-intercepts are 3 and -1. So you feel the pattern here? Again, set 3x squared equal to 0, and you get 0. And there is your x-intercept. Set this equal to 0, factor, and you'll find that you're crossing at -4 and 2. So really consistent pattern, right? Oops. Set the top part, the top of the rational function equal to 0, and that finds x-intercepts. Awesome. How do I figure out the vertical asymptotes? How do I figure out the vertical? And really, you should start at some point now be thinking vertical asymptotes. Oh, that's where I cannot divide by 0. So we basically set the bottom now and set this guy equal to 0. So again, x-intercepts set the top equal to 0. Vertical asymptotes, or where, kind of think maybe domain. Where can this guy not equal 0? And so if you look here, in this example, if I set this equal to 0 and solve, I get imaginary roots. So this guy has no vertical asymptote. He just cruises right through the whole graph. Next example. Oh, you didn't just do that to me. And here we go. So the example 2, if we set the denominator, sorry, my system just crashed. Let me get my pen back. Let me go back to full screen. And so here, it set the denominator equal to 0. I get 2 and -2. And check out the vertical asymptotes. 2 and -2. 2 vertical asymptotes, always exciting. There's always only one horizontal asymptote, and there could be no horizontal asymptote. Here I set the denominator equal to 0 and get x equal to -2, and there's my vertical asymptote. The next guy, right, I set the denominator equal to 0, I get 2 values, 4 and -4 for my vertical asymptotes. Set the denominator equal to 0, I get another vertical asymptote, x equal to 1. I'm hoping you see the pattern there. So those two concepts are quite straightforward. Again, x-intercepts, most people are pretty, you should be comfortable, a little factoring, no big deal. Vertical asymptotes, again, should be pretty comfortable. Might have to do a little factoring, look out for imaginary roots. The real hard one is this guy, number 3. And so this is where, how do we figure out where the horizontal asymptote is? Well, there are 3 possibilities. So the possibilities, I'm going to switch to the next screen. So I came up with some possibilities. The possibility is that you have a rational function where the highest power is in the denominator. So this is power 1, this power 0. Highest power in denominator, right? 6 is bigger than 1. Highest power is in the denominator. 3 is bigger than 2. So for this case, your horizontal asymptote is y equal to 0. So again, anytime the highest power is in the denominator, the horizontal asymptote is always y equal to 0. So what happens if the powers are equal? This is x to the power 1 over x to the power 1, power 2 over power 2, power 4. And again, we're looking at the highest power, right? We don't care. This is, means nothing. We're not looking at that. We're only looking at the highest powers. When those powers are the same, it's the ratio of the coefficients. So this guy, the horizontal asymptote, is y equal to 1. In this case, the horizontal asymptote is y equal to 2, or 2 over 1, whatever you want to write. And the last one, the horizontal asymptote, hopefully you're yelling at the screen, is 3/2. Nice job. Do you yell at your computer screen? 3/2, right? The ratio of the coefficients. So this is kind of a fun one. You've got 3, for my examples, I've got 3 answers, 3 different horizontal, right? For the first case, it's always y equal to 0. And check out the last case. Look, when the highest power is higher in the numerator than the denominator, 5 greater than 3, 3 greater than 2, guess what? There is no horizontal asymptote. So looking back at the notes, that's what they're saying here, right? If this power is less, y is 0. This means the ratio of the coefficients, right? This is the a divided by b. And if the highest is, then there are no asymptotes. Realize, though, with this case is pretty interesting, that the end behavior is the same as the ratio of coefficients, and then you subtract the m versus n. And there's an example. Don't worry too much about it, but it's super cool. So here we go. This first case, we already talked about it has no x-intercepts. It has no vertical asymptote. But which case is it of the 3 cases? And you should say, hey, this is x to the power 0. This is x to the power 2. So this is the case where the horizontal asymptote is y equal to 0. And you can see it. It's right here. I'll draw it in for you. Bam, bam. So thank goodness. Not thank goodness. I shouldn't say it like that. How would I do that? How would I graph it if you had to? You basically have to plot points now. You would plug in 1, plug in 2. You'd make a table and plug in. Again, I'm trying to cut you some slack there, and you won't need to do that. Here's, the guided practice you're supposed to do. Again, nice, interesting one, right? No vertical asymptote. So domain is all real numbers, right? But there is a horizontal asymptote, and it's at 0. And then it looks like the range is pretty cool. It goes up to 3 and down, but does not include 0. So interesting graph. Whoops. Here, this guy is really exciting, right? Double vertical asymptotes. Let's talk about, we already talked about the x-intercepts, right? We set the numerator equal to 0. So you could either, add or do the difference of squares, but you should get plus and minus 3. Check it out. Ratio of coefficients. The powers are equal, 2 and 2. So it is the ratio of the coefficients, 1 over 1, which is just 1. So you have a horizontal asymptote here at y equal to 1. And now, whoever graphed this, they had to plug in points. They plugged in 1 into this function. They plugged 0 in. They plugged -1. They can't do -2. They went to -3. Then they went to -4. They skipped -4, then went to -5. So there's some, some busy work that needs to be done. Again, I'm gonna let you off the hook. Most of you are hopefully taking advanced math next year, and will do more of this. So that's good. So here's the case where there is no horizontal asymptote. Again, power of 2 is higher than power of 1. And when that case, you would say there is no horizontal asymptote. And you can see there isn't one. There's no, this guy, the function is approaching infinity, going up and up and up. That's a terrible up and up and up, but you see it. And as x gets really small, then this line is going down, down, down. And that's not a horizontal asymptote. Horizontal asymptote, you can see as the function gets bigger, right, we're converging on y equal to 1. And as the function gets smaller, we're converging on y equal to 1. So here again, you would go through the same scenario. Set the numerator equal to 0, find the x-intercepts. Set the denominator equal to 0, find the vertical asymptote. and then you'd have to plot points. So your book also said, notice that the ratio, if I subtract, that there is a behavior that y is equal to x, and you can see here there's a line, that kind of the function approaches. That's a total bonus thing if you're into that. And so here again, you can see that, if we talk about the horizontal asymptote, that because these are both power 2, that the ratio of coefficients is 3, and you can see how y equal to 3 here. And here 2 is greater than 1, so there is no horizontal asymptote. These are so hard to graph. These I find, well, they're all hard to graph. So again, you'll do some matching for me in class and just identifying things. All right, look forward to seeing you tomorrow.